Hello everyone, welcome to the part 2 session of Finite Automata. I guess we have discussed about the definition, the fantasy one and the simplest form of Finite Automata and the block diagram of Finite Automata and their components. Okay, so as we mentioned in the previous video, now we will be discussing about the mathematical representation of Finite Automata, where finite automata is basically a 5 tuple. Tuple is nothing but components or elements or members. Okay, it consists of 5 elements. So before going into these 5 elements deeper meaning, which we will be learning in our upcoming videos when we solve the actual problems of finite automata. Okay, so for now let's just know the theoretical part of these 5 elements. First up, capital Q, summation, delta, Q naught, F. Okay, so now let us see what each one actually stands for. Okay, this capital Q actually denotes a non-empty finite set of states. Finite set of states is nothing but, in our previous video while discussing the components of finite automata, you have come across something called as Q0, Q1, Q2 and so on in our control units. So these are nothing but the nodes which in finite automata we will be saying it as states. Okay, this is nothing but the summation. In our first video we discussed about the alphabets, whereas alphabet is a finite non-empty set of symbols or character set like A, B, C, so on, or 0, 1, 2, so on, or in terms of binary just 0, 1, like that. Okay, so these are the combo of all these groups is what we consider it as alphabets. Okay, so this is exactly what the summation represents. Next, Q naught. Q naught is nothing but start state and F stands for final state. In our previous video we said that machine will be having 3 states. First one will be initial, next normal, then finally final state. Okay, so this is what it actually be represented. Then next up, delta. It is nothing but the transition function. So this is the place where entire process will be taking place in the control unit. So while solving the problem we will be knowing what actually transition function are for. Okay, so here is another concept called as transition diagram. Here this is the pictorial representation resume or the rules to be written, how the entire transition will be written in terms of diagram. Okay, so first rule would be a circle. This is nothing but a state which is within an encircled with a round. Okay, it is nothing but a state. Basically it will be called as node, but in finite automata it is called as a state. Next one, this is how we represent the first state, that is the start state. Okay, where you can see there is an arrow coming to the first state. For example, we have taken Q naught as the first state. Mostly by default in most of the upcoming questions Q naught would be the first state. Okay, then you can see the simple difference between the first state or the states or nodes in the third one, where there are 2 circles enclosed for a single state. So this is exactly how we represent the first state, the final state or the accepting state. If for example if we want a machine to accept this string and we are giving this input, but it fails to accept it due to enormous conditions, or if we have given the input as wrong, we wanted to give this as an input but the machine fails to do so. So at that time this won't hold good. Okay, so if this is being accepted, after accepting it, if it is processed and the output is the same as the after processing the input, we get to know that the machine is accepting this set of strings and saying it has been accepted, then this Q1 will be the final state, stating that the machine has accepted certain set of strings or symbols. Okay, finally this is the transition. Well, Q0 on accepting A, it goes to next state, that is Q1, and this is the pictorial representation, whereas this would be the function, transition function, delta of Q naught. On accepting A input symbol, we will be transferring to Q1. Next, transition table. Transition table is nothing but finite automata can be represented in terms of tables where it will be having row of states and column of input symbols. You can see A as the input symbol here and Q0, Q1 as the initial states. So here according to this one, this function where delta of Q0 on accepting input variable A, it is going to Q1. Likewise, here in table, initial state will be represented in terms of arrow and final state will be represented in terms of mark. Okay, so this is how it actually works. You can see Q0 on accepting A, it is going to Q1. Q0 start state on accepting A input variable, input symbol, it is going to Q1. Next, Q1 on accepting A, no transition, that is no language is accepted. We all know that phi represents an empty language. Since there is no input function is taking place, no variable is no input symbol has been transferred here, so it is not going anywhere and it is not accepting any input also, so that we can say that it is not going anywhere and hence it is denoted as phi. So this is for today's video. We have learnt about the mathematical representations, transition diagram and transition table. So in our next video we will be discussing about furthermore detail about the theory of computation basic concepts. Thank you. Stay tuned. Bye bye.